Alright, so these are going to be our notes here for Unit 4, working with triangles. Alright, so the first thing we know about triangles, classifying by angles. We have 3 acute angles. It's an acute triangle. One obtuse angle, that means it's obtuse. A right angle just gives us a right triangle. And 3 congruent angles gives us a special kind known as an equilateral triangle. So it's like a special case of the acute triangle. Okay, looking at it by the angles. Triangle CDE. So I'm going to kind of highlight each thing as we work through it here. So CDE, that's this triangle here. Well, it's got a right angle, so that's a right triangle. BCE. This one looks bigger than 90, so it's obtuse. We're not going to trick you here. If it looks bigger than 90, it is. ABE. That's 3 congruent, so that one's equilateral. And BDE. Looks bigger than 90, it's obtuse. CFE. So, all looking smaller than 90. Doesn't say they're all congruent, so all we could say about that is it's an acute triangle. So that was by angles, now let's think about by sides. All 3 sides congruent is another way to go what's known as an equilateral triangle. By sides, 2 congruent is isosceles. You'll see me write iso most of the time for that. And no congruent sides is known as scalene. So looking here, JKM, I got 1 not congruent, not congruent. So here nothing's congruent. So this is scalene. KLN. Well, I got this is congruent to this, so that's 2 sides, so that's isosceles. And JKN. Well, here we got a hash mark on each side, so they're all the same, so it's equilateral. Alright, let's check out a few more of these. So, kind of briefly here. By its angles, we could say this is a right triangle. 2 sides the same, it's isosceles. Here, I don't know anything about the angles, but they're definitely acute. So it's acute. All the sides are different, scalene. We got an obtuse one, so it's obtuse. Don't know anything about the sides. So, all we can say there is it's an obtuse and scalene. Here we got a right triangle, don't know anything about the sides, so scalene. Here we got equilateral all around and equiangular. So let's go back up real quick. Let's go ahead and use the term equiangular here. So that just means all the angles are the same. And our last one here, 2 sides the same as isosceles. That angle's bigger than 90, so it's obtuse. I want you guys to go ahead and try 15 through 20 in the practice. And taking a look at this one here. So with this, we would find the distance of each. So remembering our distance formula. We kind of talked earlier about that skeleton. So, let's go ahead here and do some work. We'll do 21 together, and the rest will be left for practice. So my 3 sides here have JK, KL. Notice I'm just going in order. JK, KL, and then LJ. Or, for simplicity, doesn't matter in the order. Let's just go with JL. Okay, so square root, square root. So I'm going to go ahead and use my kind of fill in the blank here. So my skeleton, which again is a note card item. So this is just a way to ensure that I include the correct number of parentheses. Alright, going off our formula up here, you can reference it on your notes. x1, it's negative, so it gets its own set. x2 is negative, gets its own set. y1's negative, y2's positive. For KL, negative and negative, positive, negative. JL, negative, 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 negative. So, what we'd be typing here in GeoGebra is exactly how the insides looks, but do not put the square root. What that allows us to do is keep our final answers in the square root for easy comparison. So I'm going to go ahead and do these calculations, as should you. So here, you see we have two sides the same, so classifying by its size, just isosceles, because two are the same. So, at this point, you can finish up all of the problems we did not do here on number 1 is practice. You're also going to be working on number 2 is practice. So here, it's just kind of color coordinating. So blue, green, and red, just to work on some of these rules. For 3, here is also some practice. So, use what you know about the vocab to solve for our variables. Also, let's ignore this m. That was just like saying meters. So equilateral, this is equal to this, and this is equal to this. So we could set those two things equal as such. And solve. Equilateral again, so I'd start with this equal to this, or 7 equal to this. They all got x. Now to find the measure of each side for these next two, so let's say I got x is equal to 2. What I would then do is plug it back in. So I'd plug it in here, 10 times 2 is 20, minus 6, that'd give me this is 14. So that's how, let's do one of these two. So equilateral, they're all the same. So let's start with this. Solving, as we've done before. Again, a great place to reference for the notes on solving would be your Unit 2 video. So now that we know that x is equal to 8, we can plug in for each one of these. Type those in a calculator and you'll get your answers. So that'll give us the side length, a numeric value for each of them. This one's going to be very similar to number 2. Isosceles, that means that these two are the same. So then I would solve for those first and then plug in to find those side lengths. Isosceles again, these two are equal to each other. And you know what? For this one, let's just focus on numbers 1 through 5. The rest you're welcome to do, but I'm only checking just 1 through 5. Once you've completed that, you can go ahead and move on to 4. Alright, so taking a look here at 4, our notes. Triangle sum. If I add up all 3 of these angles, no matter what they are, it's always going to be 180. Exterior angle, if I do angle 1 must be equal to angle 2 plus angle 3. Again, great note card items to have. Alright, so here we can work through a large number of these problems together. Alright, let's see what we got here. So for 1, let's think, we're finding angle 1 here. Okay, so these 3 angles, let's call angle 1x. That means they all need to add up to 180. Same side of our line, let's combine. So x, or angle 1, is 119. I will leave question 2 as a practice. Going on here to 3. We're trying to find our angle 1, so let's call it x. Well, this is exterior angle, so this has to equal these added together. So that missing angle is 25 degrees. Alright, let's try 4 together, and I'll leave 5 to practice. So for 4 here, okay, let's start with angle 1. Well, if we call it x, these 3 have to add up to 180. So let's see, that gives me... So 1 is 30. Now, let's think what we could find here. Well, let's look here at angle 3 next. These are on the same line. So anytime you have 2 angles here on the same line, they need to add up to 180. So you could do 84 and 3, I'm going to call my y here. Set it equal to 180. .96. Well, if this is 96, now these 3 have to add up to 180. So I can do angle 2, we'll call z. Let's see, 139, 139. So that one, 41. For this one, I'd start with angle 1, then 2, and then find 3. Alright, let's take a look at 6 here. So, angle 1, well, these 3 have to add up to 180, so let's call that x. Add them up, it should equal 180. These are vertical angles, so 2 is just equal to 61. Here, these 3 angles add to 180 to find 3. A great place to look for notes on angles if you're having trouble with some of the vocabulary would be to look back here at Unit 3A. Okay, BC bisects ACD. So that means that this angle, 2 and 3, have to be the same. So if I call them both x, looks like they add to 90, so x plus x since both of these are going to be 45. So 2 and 3 are both 45. From there, you should be able to pretty quickly find the others. Alright, we'll go ahead and skip 10 and 11 and 9. I'm going to challenge you guys to figure out number 8. I think we can. Key idea here is that 1, 2, and this right angle here all need to add up to 180. Here, okay, let's do one of these together. What should these three add up to? Well, they're in a triangle, so it must be 180. Doesn't matter what order I'm adding these in, as long as they're all on the same side and equal to 180. So let's start with our like terms. Again, for more examples of combining this, Unit 2 is a great place to go. Give me 25x, and combining my numbers, that would give me negative 20. So we got x is equal to 8. Now, to find each side length, or my angles here, D, I would plug in here. 5 times 8 minus 2. Here, 9 times 8 plus 3. And here, 11 times 8 minus 21. Algebra, calculator, boom, answers. 13 similar to 12. And 14 we'll kind of talk our way through. So here I have an exterior angle. So this one must be equal to the sum of these two. So this one and this one. Solve for x, plug back in, we'll find our answers here. Once you guys have gotten through that, we're going to finish up all the problems on here. Then go to 5, and you're going to complete these problems as well. For this one, let's work on 1 through 4. 5, 6. And we'll leave it there. So just working on problems 1 through 6. So once we finished up with 5, numbers 1 through 6, you're moving on to 6 for some more notes. Alright. Alright, good night. So, again, my bad there, guys. Someone was saying good night to me, so they are heading up, but I'm getting back to work. Alright, so for 6, we're going to do a couple of these problems together. We're going to do 1, 4, 7, and we're actually going to skip this chunk here. So let's just do those 3 together, and we'll finish the missing ones as our practice. Alright, so back up here. Now, what this is basically saying is, if these sides are the same, the bottom angles are the same, or the angles below them. So if these are congruent, the angles are congruent. If the angles are congruent, then the sides have to be congruent. Alright, so let's see. These are the same, so if this is 68, boom, also 68. So J, 68, K, let's call it X. It means if I add them all up, they gotta equal 180. A is 44. These problems are very similar here. Well, these are the same, which means these are the same. So we'd set them equal and solve for x. For number 7, these are the same. Boom. These are the same. Set them equal, solve for x. Alright, so for the rest of this on note 6, you guys are just finishing up the problems 1 through 7. Moving on to our next set of notes here, we're going to look at 7. So let's see here. We'll do a bit of these together. Alright. Big idea here, congruent triangles. So again, we're in 7. Okay, so congruent triangles. Triangles with the same blank and blank. Sides and angles. Basically means everything is the same. The letters may be different. We might name them different, but these are the same triangle, just different labeling. So all sides and angles are congruent. The key idea is corresponding parts. So a congruency statement. We're going to use this little symbol here. So instead of an equal sign, we're using congruent. So it's an equal with a squiggly or a tilde on top. Key idea here is order. So here I have A. A has one line. D has one line. That means starting off my congruency statement, A and D are my first letters. B has 2. E has 2. So B and E, my second letters. Same bit of logic, C has 3. F has 3. So those are my third letters. Writing a congruency statement is very key so we know what lines with what. Now, our last one here, C, P, C, T, C. This means that corresponding parts of congruent triangles are congruent. It's a big theorem, but basically it's saying if we know these triangles are congruent, the parts that match up by default are congruent. Alright, so just a little bit of practice here. We'll do one together. Okay, so if I think about angle J, that's the first thing, must be congruent to angle first thing P. Second thing, angle K. Third thing, angle L. Following that order, well, K is the second thing, must go with Q. L is the third thing, must go with R. For the sides, let's think about naming a segment with these first two. So let's go with JK. It's the first two, so it must be congruent to the first two. PQ. Second and third, KL. Must be congruent to second and third, QR. And let's go with LJ. So 3 then 1. Must be congruent to 3 then 1, R then P. From there, you guys can go ahead and try 2. Alright, let's take a look here at number 3. Alright, so first thing when we're given a statement, helps to kind of label things. So, KMP. So I'm just going to label these 1, 2, 3. AYC. 1, 2, 3. So I like to use numbers. You can use letters, you can use shapes, whatever you want. So let's think. KM is congruent to, let's 1, 2. So 1, 2 is AY. CY. 3, 2. Pay attention to the order. 3, 2. PM. PK. Let's see, that's 3, 1. So 3, 1 would be CA. Angle Y. Well, that's angle 2. So angle 2 over here is M. K. K is 1. So on my other triangle, 1 is A. ACY. 1, 3, 2. 1, 3, 2. So KPM. Triangle MPK. So MPK, that's 2, 3, 1. 2, 3, 1. YCA. YAC. That's 2, 1, 3. 2, 1, 3. MKP. So again, just kind of labeling, matching up. It's usually your best bet here. Alright, we will do, let's see a good one here. We'll skip these ones. Yeah, you can skip some. So let's go ahead and do, let's skip 6. I'll do 4. You guys can leave 5 for practice. So first step, STW. STW. BFN. BFN. Okay. We're looking for BN. So BN is 1, 3. Well, 1, 3 over here is SW. That's 9. So that looks like SW, which is just 9. TW. TW, that's 2 and 3. 2 to 3 is 14. So that looks like FN, which is 14. Actually, I think you guys can handle it. Just with a little bit of algebra in there, but the same kind of setup. Let's check out BF. So BF is 1 and 2. 1 and 2, ST, which is just 17. W. Well, W is angle 3. So angle 3 is N, which is just 82. B. That's angle 1. Angle 1 over here is S, which is 67. F, that's angle 2. Angle 2 over here. I don't know that angle yet. But I do know angle W is 82. Now I have 2 of the 3 angles. So let's see, this one here would be 82 plus 67. And let's call it, let's call this angle here, oh, I don't know. Oh, I was finding the wrong angle. My bad, guys. So we're looking at F. And I don't know T. But, kind of 2 ways we can do it here. So, these are the same. So if this is X, this is X. So we can use that same strategy I was using there. So W is 82. So 67 plus 82 plus X has to equal 180 because they're all in the same triangle. Solve, we'd get our answer here. At this point, you guys are working on 5 and 6, as well as anything we didn't complete up here. Once you finish up with note 7, we are going to move on, complete your practice, and we're going to go to 8. Alright, so we are on 8. Talking about proving triangles are congruent. The big ones we're going to focus on, we're actually not going to worry about hypotenuse leg. Side, side, side. What this means is by whatever means I get, I can say that all 3 sides of one triangle are congruent to all 3 sides of the other. Side angle side would mean I have some sides congruent and that angle between them. So that's the idea of included angles. It's between your sides. Angle, side, angle. So here again, it's an included side. So it's between my angles. Angle, angle, side. So here, the order AAS. So some of the justification here why sides might be congruent, it's given. It means you're literally told it is. We might know it's a midpoint, so that's called definition of midpoint. Or what's known as the reflexive property. So sides are always congruent to themselves. Angles, again, we could have a given. We could have vertical angles, all of our parallel line things here, and our bisecting ideas. So again, if you're looking and seeing some confusion here with these angles, go ahead and take a look back at 3A, where we talked a ton about those. Alright, so thinking about our corresponding parts of congruent triangles are congruent. Let's think about some congruency statements here. If these things are congruent, well, let's see here. We got angle A, congruent. Angle D. I could say angle C is congruent to F. This should look pretty familiar, so I'm going to kind of skip past this now. Okay, let's check out a side, side, side example. So there's our definition. Now, we see AB and DE are congruent. So notice the order. AB, DE. BC, EF. CA, FD. So, if those things are true, then triangle ABC congruent to triangle DEF. Here, some more examples following that same type of logic for each of these. Again, do not worry about right triangle congruence. Alright, let's get into some examples here. So, let's take a look at here. We're going to look at comparing side, side, side versus side angle side. So number one, okay, I have a side. I have an angle and a side. Let's see if I have the same thing here. Well, one line and one line, angle and angle, side and side. Now the key idea here is the order. So let's just name these ones 1, 2, 3. So if I want to go ahead and say triangle 1, 2, 3 here, so Q, Y, T, congruent. We got a side angle side, so I know it's by that. But let's write this statement out. So 1 and 2, the key idea here is our angle, right? So my angle is 0.2. So here my angle is my 2. With one dashed line is between my 1 and 2. One dashed line, my 1 and 2. Between my 2 and my 3 is my double dash. So double dash, 2 and 3. So I went 1, 2, 3. So here I'm going to go 1, 2, 3. So C, K, P. And it's by side angle side. Let's take a look here at number 2. So cool thing we kind of reference is what's known as the reflexive property. That refers to this line. So seeing how this line is kind of in both triangles, we can always say it's congruent to itself. So let's start with this left triangle. Let's just kind of label it. 1, 2, 3. Okay. So I see I have one set of congruent, another set, and that middle line is congruent to itself. So I know we can start off. You can either write the by at the before or beginning. I'm going to write the start this time. So by side, side, side. Well, let's label this triangle. Okay, so 1 to 2 has a single line. So 1 to 2 can't be my double. Let's think here a bit. So 1 to 2 has a single line. Well, if I try doing it here, that don't work. So the single line here gives me 1 and 2. My 2 to 3 has 2 lines, so this one must be 2 to 3. So if I want to name my first triangle 1, 2, 3, it'd be A, D, C, and that'd be congruent to, so since I went 1, 2, 3, I'm going to go 1, 2, 3, C, B, A. Now, your answers can be a little bit different depending on how you label triangles, how you label the numbers, or you might have the same labeling, but just write them in a different order. Either way is totally fine. Again, there's no certain way I expect you to do it. The rest of these will be left to practice. Moving on to 10. Let's pick some problems here. Let's do 1. Notice this is congruent to itself. 3. Congruent to itself. 7. 11. Remember, not congruent is always an option. If you can't prove they're congruent, you say they're not congruent. 2. Remember, it's congruent to itself. 4. 8. Look at these vertical angles here. 10. And that'll be it for this practice. Once you've completed that, you're moving on to the study guide and completing all problems here. Once you've completed the study guide and checked your answers, all you have left for this unit is to successfully pass the Unit 4 exam. Best of luck.